looks like we're all here. Alright, so today's lesson is not gonna be that hard. It's gonna be a little bit easier because we are having a test this week, right? So I'm not even giving a lot of homework either. All I'm doing is a little easier. So it's more conceptual than calculation. So we will look at that, and then I'll talk a little bit about the homework. Then we'll go from there. Okay. Before we do that, I need to connect my phone. Is almost out of battery. Give me 1 sec. All right. Hello, guys. How are you guys doing? You guys still hanging in there? Shelter in place has been extended for a whole month again. I don't even know, like, when it's finally gonna be lifted, but I'm the same way as you guys. Every day feels the same. Yeah. Well, so shall we talk about the assignments? So, alright, here we go. So, today we're going to talk about 3D figures. This is just a start. Later on this chapter, we're going to talk about how to find the volume and surface area of all these stuff. So, here we go. So, we are going to explore (3D) figures. 3D means three-dimensional figures because it has depth on top of length and width, right? Figures. And we're not even going to calculate much, to be honest. Okay. And their characteristics. Is that how it's a character? I haven't. Tell me I'm spelling it right. Am I spelling it right? Type in the comments. My goodness. Okay, so there are several things to three-dimensional figures. There is these flat surfaces are called face. Vertex is the point, the corner. Edge is the straight edge. The intersection of the two planes is called an edge. Okay, and vertex obviously is the point at intersection of three or more faces. Yeah, I've listed the definition all here. Okay. Anyone know what a polyhedron is? Despero? Oh, there's an A in between, huh? So what does the word polyhedron remind you of? What does the word polyhedron remind you of? Polygon, right? Polygon is two-dimensional. Polyhedron, you can think about it as three-dimensional polygon. So what is a polyhedron? Is basically a 3D figure or solid made by joining polygons. Okay? So it usually contains three pieces: face, edge, vertex. Okay? You still okay? All right. Before we continue, just look at this. Okay, can you count how many faces, how many edge, and how many vertex? Can you count? How many vertices, how many faces, and how many edges? So V is 8. What else? 12 and 6, right? So 6, 12, 8. So, for any polyhedron or polyhedron, for any polyhedron, okay, you can go try this at home as well. There's always a relationship called the following: F plus V minus E is always going to be 2. This is a famous guy named Euler. It's called Euler's formula. It looks like Euler, but it's named Euler. Okay. This Euler guy will appear again in calculus, but don't call him Euler. Call him Euler. Okay, Euler. Okay. If you call him Euler, people know that you don't know math. Okay. If you call him Euler, then people know, like mathematicians will respect you for that. Okay. Name is Euler, not Euler. Okay. Euler. Okay. This relation holds true for any polyhedron. Okay, you can use any of them. Obviously, cylinders aren't polyhedron. Okay, it needs to be polygon. Circles aren't polygons. Okay, so let's look at the different types that we have. These are all the types. Okay, and typically, the three-dimensional figures have two main differences in terms of polyhedron. The first one is called prism. Prism is when you have the two bases that are congruent, top and bottom. Okay, that's it. And then you're connected with some sort of connection. Okay, and it has some sort of height. Cylinder is basically the circular version of prism, but we don't call it prism because it's not cylinder. I mean, it's not polygon. Okay. Same thing. Pyramid is when you only have one base. You end up having one vertex only on the sharp end. And cone is pretty much corresponding to pyramid, but in a circular form. And the way we name all these is based on the base polygons definition. So like triangular base would be triangular prism, triangular base pyramid would be triangle base pyramid would be triangular pyramid, and so on and so forth. Okay. Any questions so far? All right. So let's classify each of these. Okay. So first of all, look at this. You have to first identify the base. Okay. How many? Oh, so first of all, is this a pyramid or a prism, or what is it? Tell me. Where is the base? Isn't the base right here? That's the base, right? So, base is a pentagon, so we call it a pentagonal. And it only has one base and it ends up all converging to one point. We call it a pyramid. So it's a pentagonal pyramid. Okay. Now, you then count vertex, edges, and bases. So how many vertices? 1, 2, 3, 4, 5, 6. Right, 6 vertices. How many, oh, why did it say bases? It's supposed to be faces. Interesting. Okay, faces, okay. So faces, oh, they say name. I don't want name. Let's count, okay? Don't name, just count. We're gonna count, okay? I mean, we can name them all, but there you go. It's just listing all the lines, right? Or all the points and all the faces. But that's a lot of work. So let's look at this in terms of numbers, because we just learned Euler's formula, right? So how many edges and how many faces, how many vertex, how many edges? Yeah. Okay, so let's count faces. I have base is a face, and then each side is a face, so that's also 6. Is that right? And then finally, number of edges. How many edges are there? There's 5 in the bottom. 1, 2, 3, 4, 5. And then 5 on the side, so 10. Does it work? Euler's formula. F plus V minus E, right? That's supposed to be 2, right? Is that true? 6 plus 6 minus 10 equal to 2, right? Does that work? Alright? Alright, let's do the same for the right side. And while you do that, let me take attendance, right? So name this and let me take attendance. So if you're here, type here again. Okay. Make sure that got everybody. Alright, I got everyone. Alright, so if you look at this, what should be the base? At first you would see it would seem like a common mistake here is some people like to say this is a rectangular pyramid. Okay? What's the problem with that? What is the problem with that? Why is this not a pyramid? Why is this not a pyramid? Or is it a pyramid? I don't know. Tell me. Tell me. Tell me. Has two bases, right? See? One here. One here. So it's triangle. So it's triangle, so you have to kind of lift it up. So it is a triangular, can't spell, triangular prism. Two bases, okay? Triangular prism. It's a prism if you, it's two bases, right? Triangles, so triangular prism. Alright, how many faces, how many vertices, how many edges? Two bases, as you say, and because it's triangle, you have one face here, and one face down there, so it should have 5 faces. Vertices, you have 1, 2, 3, 4, 5, 6, right? 6. And then finally, edge, you should have 1, 2, 3, 4. Oh, sorry, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 9 here. Okay. So once again, 5 plus 6 minus 9 is 2. Okay. It works. How are we doing? Good? Good. All right. Good. Let's flip it over. I'm problem flipping. Okay, so talk a little about a net. Okay, so net is basically, you know, like when you were younger. Sorry, maybe you still played it with this. So basically, what you do is you, like you had a cube and you open it up. It looks like this. It shows the 3-dimensional figure in 2 dimensions. Okay, so there are different types of net. So we're gonna describe each of them really quickly. Then we need to determine if it's a polyhedron. Okay. So number 1, is this a polyhedron? Does this combine into 3-dimensional figure? Does it work? Is this a polyhedron? What kind of figure? Isn't it it's a cube, right? It's a cube, or you can call it, if you're really, it's a rectangular prism. If you want to, oh, I can't spell for some reason today. Right? Either way, okay? And you can tell because, I mean, this is a typical shape. What about this one? Is this a polyhedron? Does this work? You add these 2 upsides, right? And then this should be what? What kind of figure is this? Okay, what is it called? This is, base is a triangle, so I'll put triangular. And this is going to be a pyramid, and pyramid. Okay, triangular pyramid. Not gonna be a rectangular pyramid because your base is triangle. Okay, when you fold it up, it's a triangle, right? So it's a rectangular pyramid. Oh, by the way, speaking of which, you know the pyramids that are in Egypt or ancient Egypt? What kind of pyramids are they in terms of geometry? Have you ever explored that before? What kind of pyramids are in your is it triangular? Go look it up, okay? Isn't it base squared, right? And then you get a right. So your ancient So your ancient Egypt pyramid, the word pyramid usually used are rectangular pyramids, okay, or square base. But square is a rectangle, right? So it's a rectangular pyramid, or you can call it a square pyramid, same thing. Okay. All right. Look at these two. What do these two make? What do they make? Okay. A cone and a cylinder is correct. A cone. And this is a cylinder. Cone. Cone. And this is a cylinder. Okay? I'm not good at spelling today. It's probably because I haven't been writing a lot of things. Cone and cylinder. Okay. Are cones and cylinder polyhedrons? Are cones and cylinder polyhedron? Are they polyhedron? Is it a polyhedron or no? So they're not. Okay, they are not polyhedron because this is not a polygon. This is not a this is not a polygon. These aren't polygons. Okay, circles aren't polygons. All these, not polygons. So it's not polyhedron. Not polyhedron. Okay, they're not polyhedrons. All right. Last thing, or one of the last things we want to talk about is cross-section. Cross-section is the intersection of three-dimensional shape in a plane. So basically when you cut it, what does it look like? Okay, so like when you cut a watermelon, it looks like circle inside, right? Like when you guys cut watermelons? Yeah, when you cut a watermelon in half, right? There's a watermelon, you cut it in half. What does it look like? 1, 2, half hemisphere, but the cut section is circle, right? So let's see. If you cut it like this, what would it be? You just cut it at a point, so obviously this will be a point. If you cut it from here, what does the cross section look like? Well, it kind of already drew for you for a cone. If you cut right in the middle, you see this? That's a triangle, right? Triangle. What about this? 1, 2, 3. This cross section here. That will be a pentagon. Okay? All right. Any questions for these ones? So, last thing, so in one of the problems that I'm just being precautionary, okay? So it has some sort of, so I have a flag, okay? I have a flag that looks like this, okay? It's a triangle. Oops, can't draw well. It's a triangle like this, so that's a flag, right? If I rotate it like this, really fast, what would the shape look like when I rotate it? Really fast. Okay, if I rotate it really fast, what would it look like? Okay, if I have a flag, that's a triangle, right? If I rotate really, really fast, what would it look like? So you rotate from here, so that means at a very fast pace, this should at least have a reflection. But also because you're rotating really fast, so this edge should form a circle, right? So if you rotate really fast, you should get a cone. Right? Should get a cone. Because you're rotating really fast. Is that? Can you visualize it? I'm trying to draw it out. Does that make sense? If you rotate, let's just say, a rectangle instead, like this, then what will it look like if it's a rectangular flag? Then when you rotate it, right, when you rotate it, should, in theory, give you a cylinder, right? Right? When you rotate really fast, right? I'll redraw this. Okay. When I was younger, my drawing teachers used to tell me never do this, like never draw the edge like on the opposite end. What you should try to do instead is try to get your stroke consistent so that it forms a straight line instead of drawing it the straight line, because the stroke will be inconsistent and won't look ugly. But obviously I didn't listen, so here you go. This is when I was 5. No, 10, 9. Sorry, something like that. I forgot. It's been too long. It's over 20 years ago. Anyhow, that's pretty much all for this section. So when we are looking at this week's assignment, you should already have some homework. So there's two things to do this week: homework, okay, and test. Homework is once again on bigideas.com, right? And it's 11.4. It should be open already. It shouldn't take you long at all, I think. It's called 11.4 homework. It's due Sunday, not November, what the heck? May 11th, I think. Let me see. No, May 10th. May 10th, okay? And the test is 2 days from now. So this is also on bigideas.com. It's chapter 10 test. I think 20 questions. Okay, it will be open on Friday at 7:20 a.m. Okay, I'll put a date too. It's May 8th, which is 2 days from now. And it will go all the way to 11:59 p.m. But it should take you less than an hour, okay? It's open book. You can take all day if you want, but I think you should take about less than an hour to finish. If it take you longer, then you should start earlier. Please finish this, okay? There's no way for me to give you a credit if you don't finish this in time, okay? Also, homework also. All right. Any other concerns? Before I let you go? Any logistic questions or anything like that? All right, so looks like we're done then. So everyone have a good day. Yeah. Goodbye. It's okay, Kira, I got you. Yeah, I got you, Arna.